you ever get a sheet that says 30% of your grade is from homework, 30% is from quizzes, 40% is from tests?
Yeah.
That's a weighted mean. So what they're saying is this. If I say 40% is tests, 30% quizzes, 30% homeworks, classworks, whatever, and others, these have to add up to 100%. That means I value the test a little heavier than I value your quiz or your homework. Just a little. So when I get your test averages, I'm going to weight that average a little bit heavier than we weight your homework or your quiz. That's what they're saying when they do this. So for example, it gave us the weighted score. They weighted this 50%. They weighted this 15%, 20%, 10%, 5%. So maybe your teacher says, well, your tests are weighted 50%. Your midterm counts 15%. Your final exam counts 20%. Your computer lab's 10%, your homework's 5%. Now when you get a grade for each section, all your test averages came out to 86. Your midterm was in 96. Your final was in 82. All your lab work, 98. You did all your homeworks, 100. They can't take this and add them together and divide by 5 because of this. One has a higher weight than the other. Which one has the highest weight on it? Test. This is 50% of your grade. So it has to reflect 50% of the weight of that average. So what we do is we take this and we multiply this by 0.5 and we get this. We multiply 96 by 0.15, keep the decimal, we get this. 82 by 0.20, we get this. 98 by 10%, 9.8. 100 by 5%, 5. And then we take this total and we add them all up and we get your grade. So your test averages had the most impact on this. So if your teacher says 30%, 30%, 40%, you take whatever that category is, take that average, multiply it by that amount, and then you add them all back up together. Okay? This is called a weighted mean. Okay? And a lot of teachers score by that. I used to do this, and then I went to a point system. My point system, I kind of like that a little bit better because I can kind of like almost do the same thing as weighting, but without having to figure all that at the end. And my program does it anyway, but I usually do it so that like all your articles are equivalent of a quiz grade. I kind of do it, your homeworks are a little bit less than a quiz grade. Homeworks, classworks, I don't weight as much because we mostly do them in class. Now, the only other problem, let's have you try one. All right, so now, let's try this. We're going to replace your final exam, this guy, with a 98. Now, what would I do to get your weighted score? If I replace that 82 with a 98, what should I do to get your new weighted score? Do we do all my columns? Just the one. Because this is based on a percent, kind of like your circle graph. This part's not changing. This part stays the same. What happened is this. So now I'm going to multiply 98 by 0.2. What do you get when you multiply 98 by 0.2? 19.6. So I'm going to replace this number with 19.6. And then I'm going to add them all down. So it's the same as if I added 3.2 here. Look what it did. It raised your average to 91.8. If I put a little bit more, gave you a little higher on your final exam, because that's 20% of your grade. This is 20% of your grade. If I changed this instead to 98, would it have a smaller impact or a greater impact? Greater, because that's 50% of your grade. So that's what the weighting takes into account. And the only other thing that we have to worry about is sometimes you guys get a frequency distribution where you have a frequency chart. So you have all your values in here, and then you have frequencies. And we had you put in your calculator yesterday is if you're going to do this in your one versat, you're going to say one versat, L1, L2. Now I had somebody in my 7th period class that he actually used only L1. He took this, he put it in twice. He took this, he put it in 4 times. And he took this and he put it in 9 times. Is that okay too? Rather than doing the L1, L2? But since you can do L1, L2, you tell your calculator, this is my frequency. So we're good with that. But what happens if we have this? How do I put that in my L1? Because a lot of times in your frequency chart, we don't have one number. We have an interval, right? A class with a class width. What is my class width in that, by the way? Come on, it's not even Monday. It's Tuesday. From here to here. If I counted 0 to 9, how many digits do I use? 10. From here to here, class width, 10. How am I going to put this in my calculator? I can't put that interval in my calculator. So we have a special little thing. We use a midpoint. So we find the midpoints. Midpoint says, add them, divide by 2. And my class width is 10. Can I go all the way down with my midpoints? Yeah. So now this becomes my L1, and this is my L2. And I can still do a one versat, L1, L2. I can't put an interval in, but I can put my midpoint in. Isn't it the midpoint we use when we actually make the graph? Or the upper crust boundary, but I had you guys use the midpoint. There's a lot of reasons I keep you using the midpoints, because this is another reason we use that. So if you're going to have to put an interval into your calculator, you can. You're going to find the midpoint, and you're going to put the midpoints in. It throws everything off just a little bit, but again, how do I know where my 4 occurrences are between 10 and 19? I don't. So I'm going to give it an estimate, a midpoint, and use the midpoint. I don't know what my entries were. Someone already tabulated them for me and gave them to me. I can't put them in individually. I have to use a table. So when we do this, we're going to put our frequencies in, and we're going to use our midpoints for our L1s. Make sense? It's like the quietest day ever in here. Okay. Wait till we get to standard deviation here. It's wrapped off on me here. Alright, so take a look at number 8. Here's your class midpoint. We use the class midpoint for this. Okay? They don't show you the frequency there, but they use the midpoint. They summed up all the frequencies. If you do this by hand, you have to do the same thing that your calculator does. You have to multiply these in here. What's going on with my board today? You have to multiply all these guys in here. You have to say 48.5 times 8. 60.5 times 5. 12.5 times 6. This is what your calculator's doing when you say 1 first at L1, L2. You're telling if there's a frequency. We don't do them by hand anymore. We have a calculator. But if you were doing them by hand, this is what you're doing on a frequency chart. This times this. This times this. This times this. You're adding up all of these, and you're going to divide it by... If I move this. You're going to add up all of these. You're going to add up all of these, and you're going to divide them out. And that's exactly what your calculator does. You get to go outside? Okay. You're going to do this. You're going to put these in your calculators. This was your frequency distribution we did for your 50 most powerful women in 2012. You're going to put this in your calculator, and you're going to come up with the mean for me. So here was our classes. We did this. You have this in your notebooks. Here was this. Here was our frequency. We found your midpoints. What was your class width? 9. Take it off as something easy. Look, from 30 to 39, what's my class width? 9. From here to here, 9. We probably did this like before our 2-week break. Okay, so if I wanted to do this by hand, I would do this, if I could. I have no idea why this is doing this to me. I would do this. I would multiply them all the way down and put this in. And then I would add these up. And I would divide by how many? That's 7. How many is in my frequency? How many of the most powerful women were these? 50. I would multiply them across, add them down, divide by 50. Try it. You guys try that. Remember, we can't put your interval in your L1. So instead, we use a midpoint. And again, we don't know how many entries were for each piece. We don't have them in front of us anymore. This is going to get the closest you can using a midpoint. So do these, multiply them across, add them all up, add your frequencies all up, divide by 50. Anybody come up with a midpoint? With an average? 43.44. And I come up with another one? 54 point what? 84? It might be a little off. Check yours. Okay, so you came out with the mean. So instead of checking these by hand, since they're a little harder to do by hand, how would I put it in my calculator? How would I put this in my calculator? You put the frequency and the midpoint. So which one am I going to put into my L1? The midpoint. Good. And the frequency in my L2. So try this now. Do your stat, edit, put this in your L1, put this in your L2. It does make a difference which one goes in which one because your calculator, even when you tell it where your frequency is going to have to do this procedure and divide by your total frequency. So it's going to make a difference if it's backwards and you don't tell it the right way. Remember when you do your one bare stat, L1, comma L2. L2 is your frequency. If you put it in the opposite way, then switch them around when you tell your calculator where you put them. You don't have to go redo your table. So try this. Put this in your L1, L2, and try your one bare stat. It's going to make life a lot easier. Did you get that? Huh? It's okay. So is it easier to put it in your L1, L2 and do it from there? And did you get 54.84? Okay. Did everybody try this and get this? Anybody not get this? No? Calculator's a nice handy tool. However, if you switch them up and do them backwards, it's not going to give you the same answer unless you tell it you put it in the right one.
How would you know which one to put in? I guess I don't get how you chose a midpoint in your one.
Because normally your frequency says your X values, your frequency. So this is where your X values go. So say we just did this, and my frequency was 4, 5, 6. We would do it like this. We would tell it, I put this in my L1, I put this in my L2. What your calculator says is exactly what we did here. It's going to total this and divide by your frequency. I want it to divide by this number. So if I don't tell it which one is my right frequency, it's going to divide the other way around. It's going to make a difference. Not in this multiplication right here, but in this division right here, it's going to make a difference. Now, when we did midpoint, you just put your midpoint in here, which is basically the same thing. If in fact, you set your table up and you did this, you could tell your calculator, if you put this in your L1, L2, you could tell your calculator L2, L1. As long as this second entry is where your frequency is, it will work fine. But if you set to this one, L1, L2, it's going to take the total of this column and divide that into the total of this column, which is not what you want. So you have to remember which one is your frequency because of the way we worked it out by hand. Are we good with this? Anybody not? Okay. All right. Now, the last part is just going through some of these graphs, which I had you guys investigate these in your work yesterday. So at the end of period 2, I need to collect what you did yesterday. And if you didn't finish it, I'll give you a little time to finish it. But this is what I was hoping you investigated yesterday. The difference in these graphs. This is extremely important. If your graph is symmetric, this is a symmetric graph. How do I know which bar is my frequency? Sorry. How do I know which bar is my mode? How do I know what my mode is of this thing? The highest bar, right? This would be the highest bar. It has the highest frequency. That's my mode. That means for this thing, I had 30, I really can't see the numbers, 30 something, maybe 38 frequencies of that. If your graph is symmetric, your mean, your median, and your mode will all fall in the middle of your graph. If this is symmetric. Uniform graphs we see sometimes, not too often. A uniform graph, what happened to my mode? I see my mean and my median falling smack in the middle. Where's my mode? It's everyone. There is no mode. They're all the exact same. So there is no mode. Or they're all the same, like John was saying too. So my mean and my median fall in here, but there's no mode in here. Now, technically, in the real world, we never see a uniform graph that is exactly that even. Usually you see one and it looks like this. It'll show us a little line here, a little upper here, maybe a little bit down here, a little upper here. That's what we say fairly uniform. It's close enough to being uniform. This has a little bit of a skew to it. Where's the tail? Where's the small values? To the left or to the right? Can you see this? It's in your book as well. If you can't see this, look in your book. Oh, I can't get it. This is the most important part here. See these little tiny pieces down here? I want you to go like this with your finger. It's coming to those little tiny pieces. Follow the little tiny parts of it. This is where the skew is. This skew is left. What the skew does is pull the mean towards the skew. So instead of being uniform, if this were uniform, my mean, median, mode would be in the middle. Right now, my median is smack in the middle. My median's in the middle of this guy. But look where my mean is. My mean is to the left. This is what this means. Because my mean is skewed because of those little guys out there, that means I should use which measure to measure the central tendency of my data? Which would be my best measurement to use? My mean, my median, or my mode? What do you say, Stephen? What do you say, John?
I would say the median.
I would say John is absolutely right. Because what happened to my median? It stayed in the middle. Did it move? Because of those little guys out there? Which one did it have an effect on? My mean. So do I want my mean to be dragged off the middle? Kind of think about your test grades. If your test grades were kind of even and then all of a sudden you had some really, couple of little bad ones here, what did it do to your average? It brought it down. What's the first thing you say? Can you drop those? Can you drop my lowest grade? Because why? You want that mean to be back in the middle of your scores. You want it to be the real representation of your average. It's pulling your grade down. You say, I don't want it to pull my grade down. I want it to be back up to where I normally perform. Think of that. That's the best way to think of which one should I use. Now this guy, where's the little pieces? To the left or to the right? To the right. So look. Drag your tail to the right. This is skewed right. This means, look where your mean is. Your mean is dragged to the tail. Your mean is to the right of your median. So it's not a true middle of your data. Those little guys pulled your mean to follow it. Normally we wouldn't have those. Normally we could almost be a normal curve if it wasn't for these guys over here. They ruined our normal curve. They pulled our mean slightly towards them. Right? This is the most important part to get out of all of that, which I was kind of hoping you would see yesterday when you were doing this. That's why you were investigating this. So wherever the tail goes, that's where the mane is pulled to. Hopefully we're getting this. Any questions at all? Before you leave today, I want the sheets from yesterday in case you didn't finish them. Finish them up now. And please write this down, because today and tomorrow we'll work on these. Okay? You'll have tomorrow in class. You don't have to do this for homework. Remember, your project is due at the end of the week. I changed it to Friday.